The two platforms which we are discussing is all about orchestration and the containerization. The most important one is first you need to have a basic understanding towards the Docker containerization. So Docker is a containerization platform. Inside that we will run the containers. Okay. And when you come to the Kubernetes, Kubernetes is an orchestration platform which will manage your containers. Okay, whatever the containers that you are running. So all the containers will be running through the containerization platform or else orchestration platform. So here, before we dive into the concept of Docker and Kubernetes, let me give a small introduction about myself. And later we will have a deep analysis of what is the syllabus of Docker and Kubernetes and how we are going to work around with the Docker and Kubernetes. So we will have a clear-cut picture of Docker and Kubernetes syllabus. Later we will discuss in detail about the Docker. So before we dive into this concept, first of all, let us see what we have to see. So first things first, the Docker. We will study about the Docker. So in Docker, we need to understand an in-depth analysis of Docker, and later we will go ahead with the Kubernetes. So the Docker is a containerization platform, and when you come to the Kubernetes, it's an orchestration platform. Now, before I begin the syllabus and before I discuss about everything, let me give a small introduction towards myself. So, I am Chaitanya. I will be your trainer for the next 20 working days or else next 20 working hours of this class. And I have an experience of 13 years. And I'm previously I worked for the Windows, so I worked as a system administrator, and later I am giving the trainings for the Windows operating system since 2014 onwards. Okay, so I'm a certified Microsoft trainer, and later I have done my RHEL certification, and later I did my AWS certification, and then right now I'm a certified Kubernetes administrator. These are the certifications which I have done. And if you go to the technologies, what I am expertise in, I have a very good hand over the I have a very good knowledge on AWS, Azure, Terraform, which is an infrastructure configuration platform, Ansible management platform, Kubernetes containerization platform, Docker. Kubernetes is an orchestration platform. Docker is a containerization platform, and Jenkins. Jenkins is a CI/CD pipelining tool, and then monitoring tools like Prometheus, Grafana, and Nagios. These are all the technologies which I can handle. So right now I'm working as a senior DevOps engineer in a reputed company. And if you see my certifications, these are the certifications which I possess. I'm an AWS solution architect, certified Kubernetes administrator, Microsoft certified administrator, and RHEL certified. These are the certifications I am possessing of. Now that's about my introduction. And when you go to the next one, that what we are going to discuss in this particular sessions, whenever we are discussing about the Docker and Kubernetes, in the entire Docker and Kubernetes, what we are going to discuss. So before I dive into the concept of Docker and Kubernetes and syllabus of Docker and Kubernetes, can you please introduce about yourself and let me know why you are attending to these sessions, and do you have any prior expertise on this, or else are you into the cloud environment? So if you just give me a brief introduction about yourself, and I will tell you the prerequisites. Later we will dive into the syllabus of what we are going to learn, syllabus or curriculum of what we are going to learn in the next upcoming 20 days. Okay, 20 working days. Yes, go on.
Okay, let me go first. So I hope I'm audible. Uh, so I'm Nikhil. I'm working as a API developer. Currently, I'm into development based mainly based on Java, Spring Boot, and we are hosting the APIs on AWS, and in using Docker and Kubernetes. I have almost 12 years of experience, 12 plus years of experience. Yeah, that's it.
So are you using the Kubernetes and Docker in your company?
Yes, I am. but the scope is very limited.
Okay.
It's not like I'm not from platform team, so mainly platform team takes care of these things. We are just developers who deploy the application using some
I
you
totally understand that.
yeah.
So now I have a question for you. Do you have any hands-on knowledge on AWS
Uh,
in the sense
hmm.
creating creating instances? Instances. Do you have any knowledge on creating the instances? Instances are nothing but the EC2 instances which you are working on.
Yeah,
Okay.
yes. Means it's by from my own, not from my organization, because I completed the certification from AWS. So that time I learned these things.
Okay, fantastic. So you are having a very good knowledge on creating the instances and working around with the instances and
Right. Yeah.
creating the instances. You have a knowledge on this. That's fine. So
Yes. Yes.
this is the basic prerequisites to learn Docker and Kubernetes. Okay, so when you come to the prerequisites for the Docker and Kubernetes, what is this things? So now basically, so where we are going to deploy the entire Docker and Kubernetes. Are we going for any on-premises environment or else any virtual machines? We are not going with that. We are going with the cloud environment. Okay, cloud environment that is on the AWS environment.
Okay. Not
So
locally.
no, not locally. Locally in the sense, what I can say, we are not going to take any virtual machine. So we don't have a supported VMware or else it requires a huge amount of RAM and CPU utilization, which we cannot process from our normal laptops. So for that, our entire lab setup will be on the AWS environment. So basic understanding towards the AWS environment with Linux is necessary. Not very in deep of Linux. If you have a basic understanding towards Linux, that's more than enough.
Yeah.
So these are the prerequirements, and later you need to
Any
have a
networking knowledge?
not required, not in deep analysis, not in deep knowledge of networking, but you need to have a like basic IP address. If you understand, that's more than enough. Anyways, we are not going to touch across the IP addresses also. We will be working with the services. I will let you know if there is any requirement with the networking. So if you have a basic understanding how communication will happen, okay,
Mhm.
system to system communication or else server to server communication, how it is happening. If you have that knowledge, that's more than okay. Now,
Okay.
when you get down, these are the prerequisites, and that's more than enough. And later, what else? Yeah, that's it. And you need to have a very good laptop, which is having minimum 4 GB of RAM with good internet speed. Good internet speed, and there are some tools which are required. That is, one is putty or putty. So these are the required tools that you want to run or else to want to access any EC2 instances in AWS. You can go with the putty software. So these are the prerequisites. Okay, am I clear with this? Yes. So there is Nikhil, and I think there is one more guy who has joined. Prayag, Parag. Sorry,
Yeah.
my fault. Sorry for
Hello,
that.
hello guys.
Yeah, hi.
So basically, I'm having 3.6 years of experience.
Mhm.
So rightly, I'm looking for job, and I have seen means I work as a full stack developer,
Okay.
but I have just very little knowledge on the Docker. So I
Mhm.
work little bit with the Docker, but I
Mhm.
don't have full knowledge on that one and not with the Kubernetes. But basically, I've seen that for the backend, this is in demand that we need to know about the Docker and Kubernetes.
Yeah.
So basically, my purpose is basically I need to know like how to build the whole Docker and how it runs in the backend and all these things, how to scale up it and what kind of things you use in the Kubernetes. So that is my goal. Uh, um,
Very good. Okay. Nice. As you are having 3.5 years of experience, 3.5 years, that is what you said, right?
3.6.
3.6, anyways. So now when we get back to the points here, so the Docker and Kubernetes, whatever we are working out. So do we need to invest more and more amount of time in learning these concepts? No. So if you have a basic knowledge on Linux, or else if you have a basic knowledge on AWS, and slowly I will make you learn about the things. So you don't need to worry about how we are going to work around with all the things. Do we need to panic, or else do we need to work very hard for the Docker? At least you need to spend minimum 2 to 3 hours of time for the practicals. If you do that, that's more than enough. I
Mm-hmm.
like hearing that. Definitely, you will get a job in Kubernetes and or else Docker environment, or else any DevOps engineer position. I can say you that junior
Mm-hmm.
DevOps engineer position. Okay. So, but
Mm-hmm.
the point is, you need to maintain at least 2 to 3 hours of practicals you have to do every day. Whenever I say this is the point, so start practicing that so that that will be very helpful. And I'm very glad that I can say you that a few of my students who has uh, cleared the CKA certification or the Certified Kubernetes Administrator, so they are very settled. Okay, so that
Mm-hmm.
is what. So only the thing is, if you understand the concept and if you work around the concept, that's more than enough.
Oh,
Right.
okay, sure. Yeah, thank you.
Yeah. So mute yourself and we'll come back to that. Now, when we get back to the things, what is the syllabus of Docker and Kubernetes? So in Docker and Kubernetes, what we are going to understand. First one is orchestration. What is this orchestration? That we will come back to that later in the Kubernetes part. First one is containerization. So in Docker, what we are going to understand. So first things first, what you have to understand here is Docker is a general software. Okay, it's just an engine where it can lift up all the containers. Okay, where it can lift up all the containers in the sense. So you are having an application in general, in a general format. Let us understand in this fashion. You are having an application where you will deploy this application. You will deploy the application in the servers. So you are having a Java application or Python application, any application you are having. And where you will create this application will be installed inside the server. So which type of server you want? Either it might be a Linux server. Okay, it might be a Linux server. So in the Linux server, you will install the Java application. So this Java will have a version of 1.8 or else version 17 or version 11, depending on your application requirement. You will create the Java application and install on the server. Now, when you are running this, okay, try to understand there is a physical server. So in general, whenever you are purchasing a server, you will purchase a server in a very huge, like server is nothing but having a huge amount of resources. Like you can have somewhere around some 8 CPU and some 64 GB of RAM. Normal. So let us understand our normal computer or normal laptop. In your household systems, what you will have an i7 processor or i5 processor. So every computer requires a processor to run any computing object, either it might be a laptop or desktop or server or your mobile phone, any device which is working that requires a processor. Okay, that every device which is doing the computing things that requires a processor. So here also your server is having 8 CPUs, and whenever you see your laptop will have 8 GB of RAM. Why? It's a client mission. Okay, it is a client mission, so it doesn't require more amount of RAM. Okay, it should not. So each and every person. So let us think you are having a web application. Okay, you are having a web application where you will host the web application. Web application is nothing but just like your banking application. For example, avb.in. For example, there is a banking application, or else we go with SBI. Okay, there is an SBI banking application. You are accessing this application from your laptop, or else you are accessing this application from your desktop. But you are not hosting this application in the laptop or desktop, which means that it is a client mission. Whatever you are accessing, the end users are accessing, those are the client missions. Now, where is this actual application is stored? The actual application is stored in the servers. So Why in the servers? Why not in the client machine? So now, right now, at what is the time exactly? 7:20 p.m. At the 7:20 p.m., how many hits this particular application will get? Somewhere around some 10,000 hits. So some 10,000 users will be logging in. So if the 10,000 connections your normal laptop has to given for the users, it is not possible. Okay, so try to understand this point. For example, you are having a very small home. Okay, a very small home where you can settle with a family. And if you compare with a restaurant, or else if you compare with an what I can say, five-star hotel, there is a five-star hotel besides your home, and your home is there. Just compare this. So your home is like normal small house where there will be a single family will be residing, and when you compare to the hotel, so in the hotel there will be some 1,000 people can reside. Okay, so now what is the difference here? Because it's huge. Okay, it is huge, and number of people can be accessed. If you see, if you compare your home, it is a very little one, only a single family can be there. So in the same manner, if you are having a laptop is a client-side machine where it can only access the data. Now, when you go to the server, inside the server, you will have multiple applications running, and multiple users will be communicating with the server and getting the response from the server. So that is the reason you need to have a huge amount of resources. Either it might be 8 CPU, 64 GB of RAM, or also 16 CPU, 128 GB of RAM, 256 GB of RAM, depending on the application that is running inside the server. Now this is fine. Now, whatever the Java application that you are seeing here, it is only consuming, whatever the Java application is only consuming some 2 CPU, 4 GB of RAM. Some 2 CPU, 4 GB of RAM only it is consuming. And it is consuming 2 CPU, 4 GB of RAM. If it goes to peak load, so to the peak load, the Java application is consuming 4 CPU, 16 GB of RAM. So when it goes to the peak load, it is consuming 16 GB of RAM. Now, what about the remaining CPU and remaining rest of the RAM, 48 GB of RAM? So in the physical servers, this is the main problem. The main problem resides in the physical server is optimization of resources will not be there. Optimized utilization of resources will not be there. So the servers or else that is the applications will only access a minimal resources only. It will not go for the optimized resource consumption will not be there. Why, sir? Can't we install any application on that? Yes, we can install the application. For example, if the same Java application which is running on 17 version, if you install that, then that application will work. But if you are installing a Java application which is running on version 1.8, then what happens? So you have installed Java 17 in your Linux machine, and you are trying to install one more application which is running on Java 1.8 or else Java 8. So there will be a compatibility issue. So this server cannot work with this compatibility challenges. So now what I have to do? And there is one more application which is written on .NET. There is one more application which is written on .NET. So .NET applications are especially designed for the Windows servers. So I cannot run the Windows operating system on this Linux machine. So now what I have to do? So definitely I need to go for a new server. Definitely I need to go for a new server. And this server will be running on the Windows operating system, which can host your .NET application. Okay, here you are having Windows operating system. Of course, in Linux also .NET can be run, but most useful operating system for .NET applications is Windows operating system. So I have installed the Windows operating system on a second server. Here we don't have an optimization utilization of this Linux server. Now we purchased a new server. Here also we don't have optimized resource utilization. Anyways, so there is a loss of, like, the cost will be a loss. Okay, there is huge amount of money wastage will be happening. So to overcome this problem, now in the IT technology or else in the IT terminology, we have invented or else the IT guys has invented a new concept or else introduced a new concept called as, what is that? Can anybody tell me? What is a new concept?
I guess orchestration.
Virtualization.
Okay.
virtualization. So when you go back to 2000, 2019, 95, and 2000 years, we have introduced a new concept called as virtualization. So where we are going to divide a single physical mission into logical missions. Take an example, just a simple example so that you will clearly understand. You are having a hard disk. Okay, you are having a hard disk. Now, if you want to divide, you are having 1 terabyte size of hard disk. Now, if you want to divide that hard disk into small logical units or small units, like C drive will have 200 GB, D drive will or 300 GB, D drive will have some 300 GB, and E drive will have some 300 GB. Are you going to break that hard disk into physically into pieces, or also are you going to divide that logically into partitions with the help of disk management? How you are going to divide that? Here, for this hard disk, we are using a special utility called as a disk management. Okay, either it might be in Linux or else in the Unix. We are using a disk management to divide the hard disk logically into small partitions, so that a particular size of partition we can use for system drives, for personal use, for office use. We are going to divide in this fashion. Now, when you come to the virtualization, so like disk management, how it is helpful for you to divide the hard disk into small logical units. In the same fashion, you are having virtualization. To make you more understandable, let me do one thing. Disk management, or else in Windows, there is a tool called as disk management. Here you can see. So this is my hard disk, which is of 500 GB. So if I want to divide that into partition, I can divide that into the partition. So with the help of disk management tool. In the same manner, here you are having virtualization. So in general, there are two types of virtualizations. Two types of virtualization. What are the two types of virtualization? One is bare metal virtualization, bare metal, and the second one is hosted virtualization. Okay, so bare metal, or else we can call it as bare metal hypervisor and hosted hypervisor, or type 1 hypervisor or type 2 hypervisor. In this fashion, we can call them. So bare metal virtualization means, so we are going to purchase a new server. So what I will do, I will go to a market, nothing but the computer market. So there, what I will do, I will order for a physical servers. Okay, so I will order for a physical server. So I will get a physical server. This is good. Now, this physical server is having, for example, what I will do here is, this is the physical server which I have purchased. The physical server is having some 16 CPU and some 256 GB of RAM. This is the physical server hardware resources. These are that. Okay, on the top of that, in general, what you are going to do when you purchase a server, what you are going to do after purchasing a computer machine, what you are going to do? Anyone? Once you have purchased a machine, then what you are going to do? You have purchased a laptop, which is of i7 processor and 16 GB RAM.
Operating system.
Obviously, you are going to install the operating system. But in bare metal hypervisor, we are not going to install the operating system. Directly on the physical machine, I am going to install this VMware or else virtualization software. Like the best one is VMware ESXi. Okay, or else what I can say, Citron servers. Okay, so these are all which we are going to work out. Okay, so the best one is VMware ESXi, where we are going to work for. And if you go for the Windows, there is one more operating system, Windows Hypervisor, which we are going to use. Okay, Hyper-V. These are all directly we can install on the hardware. So once we have installed this once we have installed all this on the hardware, then what we can do, we can create the virtual machines. On the top of this VMware, we can install the virtual machines. Okay, so this is VM1. And then I can create one more virtual machine, VM2, VM3, VM4, like that I can create a number of virtual machines. For example, the first virtual machine which I have created, on the top of this virtual machine, I am going to install an operating system. This is the guest operating system which I am going to install. So it is, for example, it is a Linux operating system which I am installing. Linux. Okay. And for the another virtual machine, I'm going to install another operating system called as Windows. Okay, here I'm going to install Windows operating system. Windows. And on the next operating system, I can install, for example, here I have installed the Red Hat Linux. On the another operating system, I can install the Ubuntu Linux. Like that, whatever my requirement is there, I'm going to install all such type of operating systems on this virtual machines. Okay, so this is my VM1, this is my VM2, and this is my VM3 and VM4. So I will leave the VM4 as this. Okay, so these are the virtual machines which we are having. Now the virtual machine 1 requests the resources. Virtual machine 1 wants the resources from your hardware. So what is the current requirement of virtual machine 1? So virtual machine 1 wants 4 CPU, some 16 GB of RAM. 16 GB of RAM. So that will be collected from your physical hardware by your virtualization platform. This virtualization platform will collect the resources from your physical hardware and give it to your virtual machine. On the top of this, what I can do, I can install an application. For example, this is my Java related application which is running on Linux machine. So this is my app 1. Okay. And later on Windows, I can install a .NET related application. This is my app 2. This is my app 2. And on Ubuntu, I can install Python related application, which is my app 3. Okay, like that, I can install whatever the number of applications that I want to run. I can run on a single physical hardware. So previously, if you see, I want more number of hardwares there. I want more number of servers. In this particular perspective, if you see here, I want more number of servers. But when you come back to this particular example, here you can have a single hardware. On the top of the single hardware, you can run multiple virtual machines. On the top of that, you can run your applications. So this is the main advantage with the virtualization. And this virtualization is called as bare metal virtualization. This is called as bare metal virtualization. So where you don't have any host operating system. Here you will have only guest operating system. Guest OS. Okay, only Linux is there, or Linux, Windows on top of virtual machine, whatever the operating system that you are installing. That is the operating system. On the top of that, you are going to run your applications. So this is the bare metal. So when you come back to the next one is a hosted virtualization. Hosted virtualization is as similar as this bare metal virtualization, but only the difference here is on top of your hardware, you are going to get an operating system. You are going to get an host OS. Either it might be host OS, either it might be Windows or Linux, or a number of operating systems are available. So the best hosted or else hosted virtualization softwares are VMware Workstation. The best ones are VMware Workstation. Okay. Next one is, next we are having KVM, kernel based virtual machine in Linux, like that VBox, VirtualBox, which is designed by Oracle. So these are all available for you. So this is the main difference between the bare metal and the hosted virtualization. Now, what is the main drawback of this entire virtualization platform? Now, do you understand what is the difference between virtualization on the physical server and how many types of virtualizations? Any questions here? What did you understand? Why we are learning all these things? Is it relevant to our Docker? Of course, it is very relevant to our Docker. I will tell you why it is relevant within short span of time. I'm going to tell you that. But do you understand the concept between the bare metal and hosted virtualization?
On bare metal, we don't have host operating system, while another one we have host operating system.
Yes. Okay. So now, so the main point what you need to understand here is why we are get reading or else why we are coming out of this virtualization platform. Your containerization is also one type of virtualization. Your Docker is also one type of virtualization. So this is the hardware virtualization. Whatever you are seeing here, this is called as hardware virtualization. So which means that from hardware level, we are going to work. Okay, this is called as hardware virtualization. Whatever you are, we are talking from tomorrow or from today onwards about the Docker and Kubernetes, that will comes under the software virtualization or else operating system virtualization. So here, what we are dividing the hardware into logical units. Okay, we are dividing the server into logical units as a virtual machines. So this is from the hardware level. But when you come to the Docker, Docker comes around the software virtualization platform. Now we will come to the Docker within short time. But first things first, why we are coming out of this virtualization? We are not coming out of any virtualization platform. But the things here is your AWS EC2 instances. You are having knowledge on AWS. The AWS EC2 instances, whichever you are working around, those are also the virtual machines. And in Azure, whatever the virtual machines that we call, that is also a virtualization. In GCP, any cloud is working on the virtualization platform only. Whatever the cloud instances, Oracle Cloud, or else in VMware also you are having a cloud called as VMware Cloud. Any cloud is working around with your virtualization only. Whatever the EC2 instances or else virtual machines that you are seeing in different distinct clouds, all are working with the virtualization platform. Now then, why we are coming to the Docker? Very important point. So Docker we are using for the application virtualization. What is this application virtualization? You are having an application running. So you don't want to run that application in a physical server. Previously, we have seen that there are some drawbacks with the physical server. So to overcome that problem, we are coming to this VMware. Now, why we are going from this VMware to the Docker? What is the necessity for that? So the necessity is that if you want to send or else if you want to move this entire application from one environment to the another environment, then it is going to consume lot of resources. Why? Because it is having the virtual machine, it is having a guest operating system. On the top of that, you are having the application. So if you want to move only the application from one environment to the another environment, that will be very easy. But when you see here, you have to move the entire virtual machine. Now, one environment to the another environment. What is the meaning of that? So can anybody tell me what is the meaning of this one environment to the another environment? To move the application, what I'm saying, from one environment to another environment, the virtualization or else VM will be heavy. What is the meaning of that?
Moving the application from dev to test to stage.
Exactly. Okay. See, when we are discussing about tomorrow, I will discuss about SDLC, okay, software development lifecycle. But before I go into that particular point, any application that is created or else that you are accessing right now, right in front of you, either it might be a banking application, e-commerce application, any application, streaming application like Netflix, Prime, any application you are accessing, all the applications will have minimum of 3 stages. In general, 4 stages. Okay, what are the 3 stages that you are having? The first one is development stage. So at this stage, what happens? So you will be having a company. Okay, there is a company. So this is the IT service company. Okay, IT service company. Okay, so there is a banking guy. Okay, either it might be SBI or else it might be somewhere like KVB, any banking, private or government banking sector. this guy will come to you. Why? Because the banking sector people only know about the accounts and the money transaction things. They don't know much about the, sorry, I am not degrading anyone, just I'm telling you. So they don't know how to create this Java applications or .NET applications or a system administration thing and everything. So they definitely will come to an IT guy. Okay, so this is the IT service company. They will approach to this particular people. Not only a single people, they will approach to the multiple vendors. Okay, there will be multiple organization who will be providing the IT solutions for this particular bank. Okay, so now when they go to that particular company, they will have a bid. Okay, so they want an application and by at what rate they are going to provide, they will have a bid, and the best bidded company will get that project. Now this banking sector guy will tells the requirements. He is going to give the complete information about his requirement. So I want the retail bank, retail banking, corporate banking, corporate banking, and then I want a valid banking. Like that, he will says his requirements. So retail banking in the sense, so that is belongs to the personal. So your normal accounts, whatever the normal individual accounts that you are having, okay, that will comes under the retail banking, personal banking. Okay, now just if you go to a bank and if you open a bank account, that will comes under the retail. And when you come to the corporate banking, so in there might be a small spelling mistake, you can change it later. Corporate banking, this will comes under the organization. For example, you joined a company. In your company, you are having the salary accounts. All the salary accounts are given under a single bank. That will comes under the corporate banking. And the next one is wallet banking, like Paytm, PhonePe. These are all comes under the wallet banking. Okay, nowadays some of the banks are coming into the wallet banking also. Anyways, so this company, whatever the bank is, this bank requests the IT service company that we want all this services. So now what they will do, this IT service company, whatever is that, they will have a bunch of developers. Okay, they will have a bunch of developers. Now, what these developers will do, these developers will develop a service, like microservices or anything. So by using certain coding language, either it might be Java, okay, it might be Java or Python or Node.js, .NET or Ruby, Go language, like that. There are so many different languages. When I study, I used to have only C, C++. Now nowadays it has been like Java, Python, Ruby, Go language. Oh my God, there are so many languages across. Anyways, coming back to the point, the developers will develop their service or else develop their application in the respective languages. And now after that, there will be multiple types, like multiple types of developers will be there. So who are those developers? They are UI developers. Okay, the front end developers, they are called as UI or UX developers will be there. And UI, that is called as UI UX team. And there will be service related teams will be there. That is who will develop your application, backend application, simply Java or else Python application. And there are DBS and DBMS. There are so many different categorized people will be there who will be involving into this application related thing. Now, once this development is done, okay, the application development is done, they have to check the application in one of the environment. In which environment they have to check? For example, so they will deploy this application in a server. So this is the development environment. So they will go to the nearest data center. So inside the data center, you will have so many number of servers. So what is a data center? A data center is a collaboration or a collection of multiple physical servers where you can install multiple virtual machines. And from those virtual machines, one of the virtual machine will be given to you. Okay. In this virtual machine, you are going to deploy this application. This is the virtual machine which is given by the data center. Simply, I will call it as a data center, any data center. I'm talking about on-premises environment. Okay. Now, in this virtual machine, what you will do, you will run this application. Whatever the application that you have developed, this application will be running inside this virtual machine. Now in the development phase, what happens? The developers will do all the developing, and the testing people will test the application. How many hours the application is running, and how many TPS, or also what I can say, how much amount of load it can bear. Okay, so there is an application. So what you will do, for example, you are going to purchase a car. Okay, if you want to purchase a car, it is also an appliance, right? So but it is a computerized appliance, and that is a physical appliance. If you want to purchase a car, how you will purchase the car? First of all, you will check all the required things. Okay, whatever you want, you will check the features, and you will go for the safety rating, whether the particular car is having some safety rating like 5-star rating, 4-star rating. So the safety rating you are going to check. In the same fashion, what testers will do, the testing people will analyze the entire application, and whatever the client requirement is there, whether that application is having all the client requirements, is there any fault, or there are any bugs in the application, everything will be tested. And load testing also they are going to do. What is meant by load testing? For example, this bank website, whatever the bank website is there. So the banking people are normally running every day. They are running the internet banking application normally. Suddenly, some in the festival season they have announced an offer. So the loan rates will be very less, and whatever the amount, the FDs, whatever you are depositing, that rate will be very high. So now what happened? The number of people who are accessing their internet banking will be increased on that application. The load will be there. If there is any offer that is given by the bank, obviously on that particular application, the load will be very high. Now, as the load on the application is very high, now what happens here? This particular application will not withstand further load. So they have to do the testing for that. So that is the testing environment. The application will be now into the testing environment where they will be doing the load testing. If the application survives the load, then they will send it to the third environment. Okay, can anybody tell me what is the third environment? First is the development and testing, and what is the second environment? From the development and testing, what is the second environment? Second or third environment? Directly, they are not going to send into that, right?
Staging will be there.
That is UAT.
Yeah.
User acceptance testing. Okay, they will be sending into the UAT environment. They will show the application for the users, and when the users accept that, then only it will be going into the production environment. Then only it will be moving into the production environment. So now here, if I want to move the entire application from one environment to the another environment with the virtual machines, it is a very heavy task for me. Why? Because I have to move the entire environment with me. Okay, I have to move the entire environment with me. The entire application I have to pack, and I need to send that application to the one environment to the another environment, which is going to take so much amount of time, and as well as so much amount of resources. This is the main problem with the virtualization. If you check out what is the main problem with the virtualization, or else virtualization versus the containerization, the first and foremost thing that they are going to say is virtualization, the workloads are very heavy. What is meant by workloads? Nothing but your applications. If I have to pack the entire virtualization and send it from one location or else one environment to the another environment, it is going to take so much amount of resources. So to overcome this problem, we are going for the containerization platform. So what is this containerization platform? The best example what I can tell you for the containerization platform is Docker. So when we go to the Docker, in Docker, we will have a containers. We are going to have certain containers. On the containers, we will be running the applications, whatever the applications that we have created. So not the entire application, but in the microservices. In Docker, we can run the application in the form of microservices, or else you can run the entire application also. So to pack that application and send from one location to the another location will be very easy. From one environment to the another environment will be very easy. Why it is easy, I will tell you in the upcoming sessions. But as of now, so we have seen the hardware virtualization. Now let us discuss about the syllabus, what we have to understand. So up to now, whatever I have discuss that is just a introduction to Docker. Why we need to go for the Docker or containerization. The first and foremost thing what you need to understand here is we are not going to discuss about the Docker. We are going to study about the containerization. Discuss about the Docker in the sense, for example, if you want to learn anything, you will open the Google Chrome. Inside the Google Chrome or Edge, you will open a tab. Inside the tab, you will have all the data. Okay. So now you are studying Google Chrome, or else you are studying the data inside the Chrome, or else inside the tab. Okay. So in the same fashion, here we are having a Docker as a platform. First things you need to understand this very carefully. So Docker is just a platform. For example, why it is called as Docker? Now, have you ever went to any shipyard? Any persons from the coastal region, or else any persons who are very near to the ports? Anyways, so have you ever seen this Docker? In general, I am asking. I am not asking about the Docker which we are learning. I am asking about the Docker in the normal life. Have you ever seen that? Okay, just forgot. Have you ever seen any ships in the movies? You might have seen that there is a very big ship where you will have all these containers. Ship. I'm talking about the ship, boat or ship. Okay, so let me go with this. Docker. Okay, let me go with the Docker ship. Here you can see this is from here the Docker is came. So what it is carrying is important for us. So what is important for us? Whether the ship is important or else the containers are important. Ship is important to carry this particular ship, or else the Docker is important to carry the containers. What is very important for us? The whatever the data or else whatever the resources that are there inside the containers is important for us. Inside these containers, we can have the iron ore, we can have what I can say textiles, we can have computers, electronics, we can have cars, we can have automobiles, like that. We can have so many things in these containers. So we want, so how these containers will be transported? To transport this container or else to hold these containers, we need a Docker, we need a ship. In the same manner, so what is important for us in the Docker? Inside the Docker, we are running the applications. Try to understand this. Inside the Docker, we are running the applications on the containers. So inside the containers, we are running the application. To hold these containers, we require a Docker application. So what we need to study here is what is this container? How we are going to create this container? What is meant by an image, container image? How both containers will communicate with each other. So that is comes under the Docker networking. How containers will communicate with each other. What is a container? What is meant by container image or Docker image? How we can create a volume. So these are all related to your containers only. So in the syllabus, whatever I have discussed here, look at that. So what we are going to learn in Docker, introduction to the containers. Next one is Docker architecture. Docker architecture in the sense how we can create a container, how we can run the container, and what are the different components of the Docker. So this we will learn in the Docker architecture. Now the next one is Docker repositories, how we can create the Docker repositories in the Docker Hub. Okay. Next, pull, create, and upload the Docker images. How we are going to pull the Docker images from the Docker Hub and how we can create the Docker images. Next one, what is meant by Docker file? So we said that to create a container, we need an image. So now how we are going to create that image? What is meant by Docker image? What is meant by Docker file? These are all the things that you are going to learn. And the next one is Docker networking. Docker networking in the sense I am having multiple containers in my Docker. So how one container will communicate with the another container. Next one is understanding the Docker volumes, nothing but the storage. Okay. Next one is Docker clustering with the Docker Swarm. So how we can maintain. So until the Docker Swarm, whatever we will discuss, that is only on a single server. When you come to the Docker Swarm, here we will have multiple servers. Okay. So these are all the concepts that we are going to discuss in the Docker. So this is about your containerization platform. I'm not going very in deep into your syllabus. Why? Because if I say in deep into your syllabus, or else if I dive in deep into your syllabus, you will get confused about that. So he is saying something, he is saying something, you will get so much confusion. So to overcome that problem, what I will say you here is, until we start the Kubernetes, I won't go into the syllabus. Okay, if you want the syllabus, you can check out in the DurgaSoft official website. There you can find out the syllabus. But as now, from tomorrow onwards, we are starting the Docker. So due to that, what we are going to do, I just gave a small introduction towards your containerization. From tomorrow, we are going to start the Docker concept, and then we will be studying about SDLC, software development lifecycle, and then we will see a few concept of AWS, and later we will dive back into the Docker. So that's about the brief introduction towards myself and towards your Docker and towards your syllabus. Now, when we get back to the things, in general, normal questions, what is the class timings? What are the class timings? The class timings are 7 p.m. to 8:30 or 9 p.m. Some days it might be prolonged to 9 p.m. also. But for demos, it will be 7:30 to 8 p.m. Okay, for the next 2 days, the one day is completed. For the next 2 days, it will be 7 to 8 p.m. Later onwards, whenever we are diving into on Monday, from Monday onwards, it will be like 7 to 8:30 or 9 p.m. Okay, and how many days? How many days or how many sessions? It will take somewhere around 20 to 25 days. Okay, max is 25 days, minimum is 20 days. So, do we have holidays on Saturday and Sunday? So for this batch, there will be 2 Saturdays and Sundays will be off, and 2 Saturdays and Sundays you will have sessions. At what weekends we will have that, I will tell you when we go into the sessions. So as of now, this is about your entire introduction towards the Docker. If you have any further questions, you can ask me.
Mm, actually, I have batch on 8 p.m. daily.
Mhm.
So I
Which
guess
batch it is that?
that is a MySQL batch.
Mhm. Okay, we'll see. We'll adjust to that.
Yeah.
Any
Mm,
questions?
okay.
Anyone you want to ask me any questions?
So will this help to clear CKAD?
That is what I said. Not very, see, you can go with the CKA. Okay. CKA, Certified Kubernetes Administrator. You
Okay,
can do that. Okay.
okay.
So once you have done that, then we can go into that next concept. Okay. Next certification. Have you completed CKA?
No.
First, we have to complete that. Or else you can go as a developer, you can go with the CKAD also. But that is something different from what we are discussing here. Okay.
So this course is from administrator perspective, you mean?
Always. See, if you go to the developer perspective also, I don't think there is much difference. Okay. You will have the same concept,
Okay,
but in a different manner.
okay,
Yeah.
okay.
Anything else? Anything else?
Is it possible to do early this batch?
Possible to do early this batch in the sense?
So, Miss, I have called with DurgaSoft. Then they told me that batch will be on 7 to 8 p.m. So that's why.
Mhm.
So, uh, Miss, I can adjust that. So I was thinking like this is 7 to 8 p.m. Then I will join again for the 8 p.m. for the database batch. So.
we will be working on the same. Okay. So if possible, I will try to shortcut that. Why? Because I have to complete the batch within 25 days. Okay. So if
Right.
possible, I will go with the 7 to 8:30 will be the minimum time. Okay. Or else for some days it will be like 7 to 8 also will be there. I am not sure. I see. I cannot give you a false promise that I will complete by 8 o'clock. You have to join the session. You can join the session. So if I give that, that will be a false promise to you. Then afterwards you will only scold me. I cannot do that. So the session will be 7 to 8:15, max 8:30. Okay, on Saturday and Sunday it will be like 2 hours of session mostly.
Okay.
Okay, that's it. Whoever are asking about CKAD, so our entire sessions, if I see the syllabus, the entire sessions will be helpful for you to cover the CKAD concept. It's
Okay.
very less. Okay. Yeah. Any further things?
And when we will get recording, if I miss any session, shall I get a
Every
recording?
day you will get the recordings. Every day you will have the documentation. So for every session you will have the documentation.
Okay.
Get that. Okay. Yeah.
Hello, sir. I am familiar with Azure, not AWS. So it
Okay.
will impact by any chance?
It will impact in the sense, see, we will be using a tool called as KOPS. Okay,
Okay.
KOPS. KOPS is especially developed or designed for the AWS. Okay.
Okay.
So now you are familiar with Azure. It is nothing difference between AWS and Azure. Okay. In AWS, what you will do, sorry, in Azure, what you will do, you will create VNet, right?
Yeah.
In AWS, you are going to create VPC. In
Okay.
Azure, you will have the subnets. If you come to the AWS, you will have the subnets the same.
Yeah.
Security groups and security groups, routing tables and routing tables. Almost everything is similar. Now,
Yes.
in Azure, you will create virtual machines. Okay. But when you come to the AWS, you will create EC2 instance.
Yeah.
Okay. So both are the same. And in Azure, when you go back there, in Azure, there is an option to create a password for the user. Okay. So when you are creating the virtual machines, it will ask you for the username and password, right? Or
Right.
else you can have the key file. Okay. In the same manner, in AWS also, you will generate a PEM file. With the PEM file, you will be logging into your servers. Is there any difference that you find out between Azure and AWS here?
Only terminology difference only.
Terminology difference is there. Apart from that, everything is similar. Okay.
Okay.
So I find Azure is a little bit difficult than AWS. Why? Because I will tell you the reason. In Azure, you will have multiple subscriptions and everything will be there, which is a little bit headache. But anyways, sorry for that. But anyways, coming back to the AWS, both are the same. Both are on the same boat, but only the difference is the terminology. That's it.
Okay.
Yep.
Thanks.
Thank you. Any further questions? Okay. I see no question.
And programming knowledge
No
of
need of
Java
programming.
Spring Boot.
No need of any program. See, if you see, I am from the system administrator background. Okay. But still I can do the concept, means you can also easily do that. I request you to develop an application. If you can do that on the Spring Boot, I can deploy on my Kubernetes cluster so that I can give you an example for that. Okay.
Okay.
Yeah. That's it. Fine then. Have a nice day and we'll meet in the next session. Bye.